Now it's trying to connect. Do you see us yet, Tori? No. Okay. Give me a thumbs up when you do. All right, we are live. Hey, everybody. This is Karen Hurd, and I've got my guest tonight, Dr. Steve Chaney. For those of you that don't know me, I'm trying to get over to the group here so I can do this, and I've got some folks. And I'm going to have to, Tori, can you tell people to, we're live? All right, great. Guys, we were just talking about how much we love technology, and this is our favorite part. So for those of you that don't know me, my name is Karen Hurd, and I have been a wellness educator for 21 years. Always kind of was interested in health, but it didn't seem to work for me. And my doctor said there was absolutely nothing he could do about my allergies. And thank goodness I was healthy, which his definition of health was not mine. And I got started on a supplement program, and within 6 weeks was off all of my medications. And it wasn't placebo effect like my allergist thought. It's been good for 21 years now. And even if it was, I'll take it, right? I love breathing. It's a good thing. So what that did was that unleashed a fire in me to help people get as healthy as they could as well. But as you guys know, when you're going online, when you're going anywhere, person A says do this, person B says do this, person C says do this, person D says do this, and now they get into a big fight and you don't know what to do at all. So fortunately for us, Dr. Steve Chaney, who's our guest tonight, authored the book, Slaying the Food Myths. And Dr. Chaney is a published researcher with 100 published studies in peer-reviewed journal research. And for those of you that may not be aware of what peer-reviewed journal is, it's not self-published. It takes several years to get an article published there. It goes through a very, very strict gauntlet. And it's quite a significant achievement to have that done. He is also an expert in human metabolism and nutrition and taught, I believe, first-year med students.
Absolutely.
At the University of North Carolina at Chapel Hill. So for 40 years, he's a professor emeritus there and a holistic educator himself. He's a cancer researcher and has often been my go-to man, whether he knew it or not, because whenever there was some kind of controversy that just did not seem to make sense with what I knew to be true in health or in science, Dr. Chaney always had the explanation. In fact, maybe we'll have him tell you about lab rats bred without ovaries or immune systems and how that affected a soy study. So thank you so much for joining us, Dr. Chaney. We're so glad to have you.
Well, I'm glad to be here. And I liked your introduction. I was actually thinking of calling my book The Great American Food Fight, but that title had already been taken, so I couldn't.
It had already been taken. Yeah. No, but it really is true. And what led you to write this book? What was the impetus for this?
Well, it started when I was teaching medical students. So I had one of the very first classes that they got in medical school. Mm-hmm. But remember, these were all college graduates coming into medical school.
Right.
And they came in believing these bizarre myths. And I'm saying, well, they're educated. They're not supposed to be taken in by these myths. And then I started giving public lectures, and I found that there were people that were also taken in by these myths. And I realized just what you said, how confusing this is to the American people. You want to do what's best for your health. You're trying to live a healthy life. You're trying to eat right. But what do? Mm-hmm. You get all this conflicting information. And even worse, some of it's bad information. So what that means is you're trying to do the best for your health, but you may actually be doing your health in. You may be doing something that's bad for your health, but you thought it was good. Right.
And everybody said it was good. One of the things I always appreciated about what you taught me, and maybe we could start here and then the rest of the questions, and that might make sense, is do you remember Family Feud? And they would say, survey said. And I always think of just saying, studies say. And why does this study say this? I mean, there's a social media meme about lemons and dandelions curing cancer. And my whole thing was, as if that was really true, Arizona would be one giant lemon grove, right? The Lemon Growers Association would be funding studies, right?
Right.
And then Big Pharma would be in there trying to synthesize it for a patent. So, and I went on PubMed and there was a little bit, but not much. So what is going on with studies that everybody has a study to prove their point?
Well, that's really the scientific method. I have a section in the book I call Secrets Only Scientists Know. Now, they're not really secrets. And yes, there are some people besides scientists that know them. But the scientific method is set up so that we try and challenge the existing paradigm. We purposely design our experiments to disprove the existing paradigm. There's no glory to be the 10th person to prove a theorem is true. The glory comes from being the first person to disprove the paradigm and therefore start a new paradigm in the process. Now, what that means is you're going to find studies on either side of both issues, of almost any issue that's out there. Scientists understand that. So when we look at conflicting studies, it doesn't bother us. We ask, what is the, if we look at the preponderance of data, where do most studies take us? And then we ignore the ones that are going in a different direction. Or sometimes, you'll get a lot of studies on both sides, and we have to ask a question: how well were the studies designed? Because not all scientific studies are equally well designed.
Even if they get published?
Even if they get published. So the really bad ones tend to get weeded out. But, there's some that, for example, if you think about it, actually, and it's very difficult in the field of nutrition, so I'm going to back up and say that. When we talk about double-blind, placebo-controlled studies, that's the gold standard. Mm-hmm. And, that works pretty well if you're working with a medicine, because you have one drug, and you're trying to see, does it work or it doesn't work? And that's pretty good to do with a placebo-controlled trial. But nutrients work together. You really want to be looking at a holistic approach. We can't test a holistic approach in a placebo double-blind controlled study. So then we go to association studies. So we say, if people eat this way, as opposed to eating another way, what health benefits or diseases are associated with those different patterns of eating? Well, here the problem is that something that we scientists call reverse causation. Now, that's just one of those big $10 words. It basically, you can think of as the chicken and egg, which came first, because they may be eating a certain way. They may have changed their eating pattern because they developed a health condition.
Okay.
Rather than developing the health condition because they ate that way to begin with. You look at associations, you can't tell the difference.
Okay. So the other thing was, and I think this was a really, really important part in some of the science nutrition top courses, or not courses, but seminars I've taken with you, is that what happens in the test tube doesn't always happen in the body.
Right.
And a lot of folks are not familiar with that. That's hence the lemons cure cancer thing. And there's a study that it does something to a cell. And this is actually your field. But can you, what is the progress there? So why is the test tube study, and does it end up in a human being or not?
Well, I've got a pretty good perspective on that because I worked in cancer drug development. So if you look at the various levels, sort of the first test you do if you want to test out an idea is you do what we call a test tube experiment. You're just running a chemical reaction. You might have mix some chemicals together and see what happens. But typically for nutrition, you would work with, you'd put an enzyme in a test tube and you'd add your inhibitor, your activator, and you see whether it affects that enzyme. And then if it seems to work there, then you go to cells. Now these are cells in a tissue culture dish. That's not a whole body. Whole body, you've got trillions of cells and they work together in a very complex fashion. Just looking at a single type of cell in a test tube, that's a very different sort of thing. But now we start to get a few other things going. So we might find 1,000 compounds that inhibited a particular enzyme. Those all might be cancer drug candidates. And then we would take them to cell culture. And we put them in cell culture. Well, some of them were taken up by the cells. Some of them killed normal cells as well as cancer cells. Some of them were very rapidly inactivated. So of those 1,000 compounds we started with, by the time we finished the cell culture experiments, we got 100 left. 100 potential cancer drugs. And then you send it off somewhere and they do animal studies. And sometimes in animal studies, it goes into the urine, never gets into the cells. Sometimes it doesn't get into the bloodstream. Sometimes now you're really killing normal cells and the toxicity is greater than the benefit. So out of those 1,000 compounds you started with, now you get to finish the animal experiments, you're down to about 10. And then then you go to clinical trials, actually doing this in humans. And out of those 1,000 compounds you started with, one actually works in human beings.
And that doesn't even, and then from there, does it get marketed?
Well, yeah. So if it works in human beings and it's got a unique mechanism of action, it's better than existing drugs, or maybe it has fewer side effects than existing drugs, yes, then it gets marketed. I mean, I was very fortunate in my 40-year career, I was able to work on one cancer drug that actually made it into the clinic. And I have colleagues who were never as fortunate. Their entire career, they were advancing the science. So that's not like they were doing nothing. They're advancing the science, creating a foundation where someday somebody might be able to create another cancer treatment. But they never were able to find one during their research career.
But at each stage, you could have a study published.
Oh, yes. And
then anybody, especially in the wellness field, could create a supplement based on a study, regardless of what happened to it.
Right. And, and a lot of times people will, develop. So first they'll pick a study and they'll say, well, this looks like a good compound. So we're going to market this. Or it might be a diet, because this particular book is Slaying the Food Myths. I'm going to come back in the fall with Slaying the Supplement Myths, so we'll get more into that. But they might look at a particular diet or a particular, but it might be in animals, or they might be looking at a particular food component. So let me give you the nutritional analog of what I just talked about.
Sure.
Let's talk about antioxidants.
Excellent.
So people, and this, I guess, gets into supplements in particular because people market a lot of antioxidants as excellent supplements. Well, there is a chemical reaction where you look at the antioxidant potential of compounds. It's called the ORAC system, ORAC. Not that that's particularly important. And again, you'll have 1,000 compounds that look like great antioxidants. Then you do the cell culture. It's down to 10 that actually work in the cell. Do the animal experiments, it's down to 10 that work in animals. And when you get to humans, there's only one of those that has biological significance. But a company can market a compound as an excellent antioxidant, even if it worked only in test tubes.
Okay.
They may have never looked at never looked at cells. They may have never looked at animals.
That's right. And the reason why I brought that up, and I only wanted to get back into the food, was I felt like that was people understand that. They understand that. They go online and they see studies show, right?
Right.
Especially, and they're not usually purchasing diets per se. They're purchasing supplements. So, and I think that dealt with, so how does a consumer who's not going to go to PubMed and analyze those, get even past the abstract? They're not even going to do that, right? They're going to go to a magazine, or they're going to go to somebody who they think boiled it down for them. How can they navigate? What can they look for?
Well, I mean, that's partly why I wrote that book, to help people, give them some guidance. But, you have to ask yourself, does it sound too good to be true? That's sort of one question to ask. One of the topics I talk about in my book is these claims from a few years ago that eating chocolate would cause you to lose weight. And, there were companies that were launched around that phenomenon. Mm-hmm. I remember going to the internet and seeing these ads that for, $5,000 you could register and they would train you to be a chocolate weight loss consultant making $50,000 a year. I mean, it was crazy. And this was one of those association studies. If you look at a cross section of people, the people who ate the most chocolate weighed less. Now, they didn't tell you which was the chicken and which was the egg.
Mm-hmm.
So somebody finally did a study over, I think it was a 5 or 10 year period. Cross section at the beginning of the study, cross section at the end of the study. Both of them showed people eating the most chocolate weighed less. But when they followed individuals for that 10-year period, the people who ate the most chocolate at the beginning of the study gained the most weight.
And it was cocoa powder.
And guess what? Those people who develop an obesity-related disease, like diabetes and heart disease, started eating less chocolate and more fruits and vegetables. I mean, who would have guessed, right? So you have to ask yourself, does it sound too good to be true? The other thing, you do this exactly the same sort of thing that I was talking about. You can usually find either in the title, well, often in the title. So the title and the abstract of every article, you can Google it. It's available online.
Mm-hmm.
A lot of the articles are online now. You don't have to read the articles, but from the title and the abstract, you can tell whether it was done in a test tube, whether it was done in cell culture, whether it was done in animals. So if it's not a human clinical trial, you should probably say, well, this may or may not apply to me.
Right. And sometimes it might not be harmful, whether or not fiber helps with cancer or not. That's not harmful to include more fiber in your diet.
Right.
But some of these other things actually can be quite bad. And I wanted to get into some of these controversies with you.
Okay.
So there are some diets out there, and I'm thinking of the autoimmune protocol diet,
mm-hmm.
which I would call a therapeutic diet. And then when I look at paleo and keto and some of these others, it looks like they took a therapeutic diet and tried to make it a universal way to eat. And I don't quite understand, even like with the autoimmune protocol, GAPS is another one. GAPS isn't as bad though. By bad, I mean as restrictive. It looks to me like they're trying to somehow concentrate the nutrition to get an effect as opposed to a healthy lifestyle. Would that be an understanding of that, or what would you say?
Well, I mean, that's an interesting way to think about it. I have some principles I tell people to look for. One of them is, and again, there are lots of things that are sort of wrapped up into this. So let's kind of go back and talk about some of the individual things you said. So the one diet fits all isn't necessarily a good idea. I call this the Lake Wobegon effect. You remember Lake Wobegon, where all the children are above average? Mm-hmm. Well, clinical studies they report the average result, but nobody's average. So let's say you do a clinical study, you put somebody in a diet, 6 weeks later, on the average, they've lost 10 pounds. Some people have lost more. Some people have lost less. Some people will have gained weight. Nobody on the study lost exactly 10 pounds. So that's one of the big differences in my book from most other diet books that are out there, because most of these diet books, the author is going to try and convince you that they've got the perfect diet, whether it's autoimmune, whether it's paleo, whether it's keto, and this is the perfect diet for everybody. What I do is I say, here are a range of healthy diets. All of these are reasonably healthy. We can look at health outcomes. That's another important point. And we can show that all of these are healthy diets. If you follow them well for over a long period of time, you need to experiment and find which fits your body best.
So let me ask you, because one of the things that I have noticed, and I think others have, because there's all these books about it.
Yes.
Is it seems to be people are feeling really bad, and overall, and that eating has become this experiment in like landmines, right? Trying to eat this, not that, work around this, do this, And I especially noticed that, like gluten, who had gluten sensitivities in the 80s, really? And we know that some people did that were undiagnosed celiac because it used to be believed that somehow celiacs magically only lived in Europe, Australia, and Canada. And I always that thought, well, what happened there? But we know they just didn't test for it here in the US. But outside of that, we didn't hear about gluten sensitivities and people not being able to eat gluten or wheat, right? Which people ate for millennia.
Mm-hmm.
Where do you, it seems to me that there's been some kind of a turning point, or are we just complaining more? What do you think? Like, do people feel this, or are they just complaining more?
So as somebody who suffers from gluten sensitivity, I can tell you it's a real thing.
I agree.
And it is increasing.
Okay.
Now, there's a certain amount of hysteria out there.
Right.
And you talked about navigating all the labels and that sort of thing. There is a name that they've given that. I think it's something like orthorexia nervosa, but it's really becoming compulsively concerned about what we eat.
Yeah, I've seen that.
It's getting very restrictive. But moving away from that, back to the gluten sensitivity, there are theories about it. There's some theories that are talking about genetically modified. Now, the interesting thing here is that wheat is not genetically modified, but it is sprayed with Roundup just prior to harvest, so it's easier to harvest. All the leaves drop off, the weeds are killed. You just go in there and you get the seeds. So so it might be Roundup contamination or something else. Some people, think it's due to the way that we, so much of the food we eat is processed. So much of the grains we eat are processed in this country. And all of those are theories. I'm not going to dignify any one of them by saying it's true, but we do know it's increasing, and we're not sure why.
Because we just got a question having to do with that. Is it the way it's processed now that may be different than years ago? I mean,
so again, these are studies where you look at associations or correlations. So we can say that we are processing foods differently. We're eating a much higher percentage of processed foods than we did years ago.
Okay.
So both of those factors correlate with the gluten sensitivity. But the same thing could be said about the amount of Roundup we spray on our crops.
Nice.
That's also increased. That correlates. But proving correlations don't tell you cause and effect. We really don't know which of these things is important. People, and that's where you think you go on the internet and you see these posts, and they're absolutely certain that it's the way the food's processed, or they're absolutely certain it's genetic modification or it's use of Roundup or something like that. Well, it might be, but we don't know.
No.
I like to look at things that we can actually prove are, one way or the other.
Okay. All right. Because we see that a lot. And we have someone in our family with an autoimmune disease. So, of course, everybody said get rid of gluten and dairy. And I'm like, this person doesn't have trouble with that.
Mm-hmm.
I did elimination, just, be on the safe side. This person doesn't have trouble with that. And no, that's not why this person, some autoimmune is just idiosyncratic, means we don't know.
Mm-hmm.
Sometimes shows up. I mean, someday we'll get an answer, but not now. So why do you think now, what about cancer rates? Are cancer rates increasing, or is it just we have more information at our fingertips?
And that's interesting. Cancer rates for some cancers are still increasing. Other cancers are leveling off because of better detection. In some cases, cancer deaths are starting to decrease because of better treatment.
Yeah.
So it's a mixed bag. Where we have really good prevention, we're starting to see a leveling off of cancer. But we don't have really good prevention strategies for a lot of them. And where we do know things that can prevent the risk of cancer, we're not doing a really good job as individuals of following those guidelines.
Can you give us a specific example?
Well, let's see. I have, in a couple of weeks, I'll have an issue coming out on colon cancer.
Okay.
And health tips from the professor. So this is a recent study. So I like to just highlight recent studies.
Sure.
And basically, they were looking. Their hypothesis was that an inflammatory diet increased the risk of colon cancer. Now, again, this is association, so it doesn't show cause and effect. But they did show
people inflamed and then try their cancer out. In other words.
Yeah. Well, we know that, for example, inflammatory bowel disease increases your risk of colon cancer. We have some indications that would suggest that that's a likely hypothesis, but again, we don't know for sure. But again, if you look, so what they found is a very high correlation between inflammatory foods. This would be red meats. Processed meats are the biggest offenders. Fried foods are offenders. Sodas are offenders. Interesting, diet sodas are just as bad as sodas, and in their study. So those were the biggest offenders. Fresh, colorful vegetables were the biggest protectors of reducing inflammation. Alcohol in moderation. One glass of wine, one small beer, those both produce inflammation. Not that I'm necessarily suggesting that for everybody. Whole grains, fresh fruits, omega-3s, all of these are things that lower inflammation. So they saw a significant correlation between the kinds of foods that people were eating and the risk of colon cancer, risk of developing colon cancer.
Okay.
So that would be an example.
All right. And then we just had a comment, and I've heard this before, back to the gluten real quick before I ask you about something else. Some people say that when they're in Europe and they eat gluten, they don't have problems. They come here. Now, I get my flour from Italy, all right? I get einkorn. But why do you think that is?
Well, again, it would fit either hypothesis, although there are some pastries in Europe that are probably just as bad as they are here. But when you travel in Europe, you're usually eating whole grain breads,
right?
And they're 100% whole grain. I mean, this is the real stuff. You got to chew on it. Mm-hmm. The other thing is they don't. In a lot of these countries, they Roundup is either banned or they use very little.
Okay, yeah. So we'll see what happens with that in a few more years.
Yes.
One of the things I wanted to ask you one more question about Alzheimer's, and then I wanted to get into some of the marketing of health and diets.
Mm-hmm.
Are we seeing increases in Alzheimer's and dementia, or is it like we're just because of social media? We have a lot more conversations than we would have otherwise. So is there an increase in that? Because I've seen some things that suggest that drugs, especially the ones that work with acid reflux, possibly statins, mm-hmm. can negatively affect gut health, and hence we're seeing this increase in Alzheimer's. Are things like that increased?
So yes, there does seem to be an increase in Alzheimer's rates. And it's kind of interesting when you start to look at diets and Alzheimer's. So the advocates of the keto diet, that's one of their big promotions is, this is going to help reduce the risk of Alzheimer's. Now, the actual data supporting that statement is fairly shaky, but it's theoretically possible, because we do know that the brain uses ketones in a very different way than it uses sugar. And sugar is sort of the normal fuel, but it can adapt to use of ketones. So it's theoretically possible. But the interesting thing is the Mediterranean diet is proven to decrease the risk of Alzheimer's. The closer you adhere to the Mediterranean diet, the better you do. And somebody designed something, a gal, I've forgotten her name, but she designed something called the Mind Diet, mm-hmm. which is very similar to the Alzheimer's diet. I mean, to the Mediterranean diet, but it's based on studies where they look at foods and their effect on cognitive decline. Mm-hmm. So, for example, she includes berries in her Mind Diet, But she doesn't specifically recommend other fruits because they don't have studies on other fruits specifically. So, it's very close to the Mediterranean diet. Those have been clinically proven to reduce the risk of Alzheimer's.
Okay.
So again, the interesting thing is you get these sort of dogmatic statements. This is going to reduce Alzheimer's. And you look at the literature and they say, but this does it just as well.
So
what's going on here?
Prevent your risk, to lower your risk.
Right.
And so let's talk about marketing. You kind of led into that when you talk about dogmatic statements. Now, you in your book, you talk about epigenetics, and I looked at that. And the new phrase I've heard is biohacking. I'm thinking, oh, seriously. So is epigenetics just another word for healthy living? When you talk about affecting the genes, but wouldn't anything we do to work with our health affect our genes?
Well, no, this is actually, so epigenetics is a scientific term. It's very narrowly defined.
Okay.
Biohacking is one of these, that's what I would call a blogger's term that's really not particularly well defined. But epigenetics is very well defined. And these are actually changes to the genes that can be inherited. And that's heritable. So you're making a change to your genes by what you eat, but that affects not just you, but affects your children, your grandchildren.
Oh, generationally.
Generationally.
Oh, the same kind of thing when they talk about trauma victims, that sometimes their children and grandchildren will have, I call it shadows of trauma, even though they never experienced it themselves. They may have similar fears, even if the person that was originally traumatized did everything possible to somehow it's in the genes.
Yes. I mean, that's not quite as well defined as the epigenetics, because you can actually measure the changes to the genes.
Okay.
So I have a chapter in there about that. But here's the thing to keep in mind.
Okay.
We know that it exists, and there's some very good experimental examples that show that it can happen. There's some companies out there that are trying to market this and say, well, we'll just look at your DNA and we'll tell you how much of which nutrients you need.
Nutrigenomics?
Nutrigenomics.
Genomics.
Yes. So here's the problem with that. You can look at a particular genetic change, and that genetic change is going to have a different effect in different people based on their total genetic background. So we can say that some of these genetic changes might be very important. They might be markers, but they're not going to work for everybody.
Okay.
And we don't have enough information. People are trying to look at snippets of the chromosome and say, well, we see this gene's change, so therefore you're going to need more folic acid, you're going to need more of this or that or the other thing. Probably they're going to have to look at the whole genome before they can really make that kind of assessment.
And that would be pretty expensive.
No, it's much less expensive than you think nowadays.
Okay.
That the cost keeps coming down. The problem is not so much the cost of doing the genetics, but the complexity of analyzing. You kind of need supercomputers to figure all this stuff out. But it's coming. It's coming.
We're not here yet. We're
not here yet.
Okay. All right. So I kind of suspected that about biohacking. Yes. One of my other questions was, wanted to talk a little bit too about the MFTR gene mutation. Why now? Why are we hearing about this now? Why does it seems to, part of it, I guess it's new, so everybody's talking about it. And I did go to your website, Health Tips from the Professor, and you had quite a discussion going on about that. And some people were really very seriously affected by it. But for the most part, that's supposed to be no big deal. Do I have that right?
That's right. That's right. So again, the geneticist term for that, again, if we go to the $10 word, is called penetrance. So you can have the same mutation in different individuals. Some individuals, it's just a minor you know, you have to make sure that you're getting adequate folic acid. So you're going to be more likely if you consume a diet that's inadequate in folic acid and you don't take a supplement that provides folic acid, you're going to be more likely to have some problems. But other than that, you're pretty normal. But there are other people who have defects in other enzymes that affect methylation or other enzymes and pathways that you require a certain amount of methylation. And so now you start to get a cumulative effect, and they can have a very much more significant effect.
And
but it's a much smaller number than these people that just go on about how important that gene change is would have you believe.
And I would think that somebody that if it was severely affected would already be under medical care for that.
Yes, you would think so. Although, methylene tetrahydrofolate deficiency is not necessarily the first thing that somebody tests for when somebody comes in with a psychiatric disorder.
Okay. But that would be coming also. We're getting some questions in, and all right, so some of these are pretty specific. You speak at length in your book about the keto diet, and one of the questions I have is it good for the body long term?
And let me preface that by saying I think this is a really important sort of general statement. Then I'll go into actually answer that question. So sort of a two-part answer. But the first part is I kind of, one of the things I could say in the book is I have a question: why do bad diets work? And the question, and it should really be phrased: why do bad diets work short term? So let's take something like the keto diet, for example. You've cut out whole food groups. You've cut out fruits, you've cut out grains, starchy vegetables, you've got some green vegetables, but you've reduced whole food groups. So when you do that, people just naturally cut back without even thinking about it. Now, I call that the cream cheese and bagel effect. So it's nice to say you can eat all the cream cheese you want, but eventually you're going to want a bagel to go with it. And so you end up eating less cream cheese. You don't think about it, but it happens. But the other thing that happens on those diets is that you're focused very much on what you're eating, because you've cut out all your favorite foods or a lot of your favorite foods. You got to really think about, what am I going to eat for breakfast? What am I going to eat for dinner? What am I going to eat for lunch? What am I going to snack on? And anytime you focus on what you're eating, you lose weight.
Okay, so it's like mindfulness.
It's mindfulness. So any of these diets will give you weight loss. Here's the other thing that they don't talk to about, because when you look at people talking about clinical studies on the benefits of the keto diet, those are short term. Anytime you lose weight, 5, 10 pounds, more is better, but even you get 5 or 10 pounds, cholesterol levels come down.
Regardless of how you did it.
Right. Regardless of how you did it. Triglycerides come down. Your blood sugar levels improve. Your inflammation decreases. So you can run all these tests and say, oh, look at all the great things this diet is doing. The interesting thing, and again, I'll give you a comparison, in terms of weight loss and in terms of the benefits you see, in terms of blood parameters, blood pressure, that sort of thing, you get almost exactly the same benefits on a vegan diet, a very low-fat vegan diet, as you do on the keto diet. Those are polar opposites in terms of the food groups you're restricting, but you get the same effect because you've lost weight, your health parameters improve. So now the question is, what diets are healthy long-term? And these are studies. So if you follow a diet for 10, 15, 20 years or more, what are the health outcomes? And there are very good studies on primarily plant-based diets, ranging all the way from vegan to Mediterranean, showing that you have better health outcomes. You're going to weigh less than the typical American, lower risk of heart attack, stroke, diabetes, cancer, tons of studies showing that these diets are healthy. In terms of something like, in terms of these low carb diets, almost zero. We don't have long-term studies. And when you think about it, you might say, well, the paleo diet and keto diet have only been around for a short period of time. And yes, that's true. The Atkins diet's been around for 50 years, almost 50 years, 47, 50. And there's no evidence it's healthy long-term.
Right.
So, if your diet's been around that long and you don't know whether it's healthy long-term, it kind of belongs on the scrap heap of history as far as I'm concerned.
Yeah, I got some comments about, would keto eventually wreck one's system?
Possibly. So again, we don't know. But here are a couple of things that we need to be concerned about. One is you're restricted in food groups. And anytime, we have 5 food groups for a reason. Each of these food groups provide different nutrients, different phytonutrients. Some provide more fiber. So, we have these 5 food groups for a reason. You're going to end up potentially with nutritional deficiencies, and they may be nutritional deficiencies that you can't fix by taking a multivitamin, because we're talking about phytonutrients here.
Right.
Talking about fiber here. So you end up with some nutritional deficiencies. Another thing is that ketones irritate the kidneys. Now, this is a relatively small effect, and it can be overcome if you drink lots of water. But I haven't seen anybody talk about how much water you need to drink if you're going on the keto diet. The keto diet actually restricts protein to a certain extent. And when we get past age 50, our protein needs go up. So we start to lose protein mass, and this is a very serious concern.
Your heart's a muscle.
Yeah. So you lose muscle mass. That's a serious concern. But the one that bothers me the most is osteoporosis. So our body has one of the things that they don't tell you when they talk about ketones is they aren't just ketones. They're keto acids. So the body has to neutralize them to keep from going into what we call ketoacidosis, which can be deadly. Now, we've got a number of systems to help neutralize those keto acids, one of which is dissolving our bone. The calcium phosphate in order
to balance the acid.
Yeah, the calcium phosphate from our bone is basic. So you can the hydroxyapatite, which is the calcium complex in the bone. When you dissolve that, that's basic. That helps to neutralize the acid. So, but if you have a constant production of keto acids, you're going to be losing a little bit of bone day after day, month after month, year after year. That's not a good thing.
Yeah. And I think that the same so if I can just wrap this up, because in your book, you go into a lot of detail on several of these popular diets that are out there, or eating plans, or whatever you want to call them. And I got a couple more questions here about Alzheimer's, and I wanted to get into a little bit about a couple of what I call ingredient wars. Is that losing weight, pretty much no matter how you do it, is going to short term give you good benefits. The question is long term. The question
and the thing about that short term benefits, that's how come even bad diets, even bizarre diets, can tell you, they're good for you.
Because the short term.
Because they look at the short term benefits.
Yeah,
Go ahead.
Yeah. And you said once you get into the 12-week, 16-week period, can somebody maintain the weight? And then I think about the body going now off balance, and it always wants to come back in. So what is it going to do to try to make that happen for itself? So when I read through your book, you come back down to basically, it's not very sexy, but what we've always known to be true: eat from the 4 food groups, heavier on the fruits and vegetables.
And whole grains
are okay.
And
they're
legumes.
Not really inflammatory, maybe unless you got something else going on.
Yep.
And that's the way to go. Now, I'm getting some questions here, a lot about Alzheimer's and whether or not it's genetic.
There's definitely a genetic component for some people. We do know that Alzheimer's does run in families, but it's not solely genetic. There are a number of people who develop Alzheimer's that do not have a family history.
Right. But anything that you could do to prevent would keep you healthier and extend your health span in the long run.
Yes.
All right. So let's go to, you've been so gracious with your time. I'm so grateful. So for those of you guys who, like I said, in the back, he goes a lot on these diets. And I wanted to talk a little bit about microbiome and why that's important. And then what ingredient that you're hearing being bashed about bothers you the most, which is the one out of all the ones that are getting bashed about strikes you as the most, the silliest?
Oh, golly. Well, that's almost a hard one, but let me choose. So maltodextrin is one that I find very amusing. So when we, anytime we eat complex carbohydrates and we digest them, in the process of digesting them, like the chain, they get smaller and smaller, and eventually they become maltodextrin in our intestine on the way to being broken down all the way to simple sugars that we can absorb. So we're always producing maltodextrin in our intestine anytime we eat carbohydrates. So the whole idea that maltodextrin is this evil food ingredient, it boggles the imagination. But let me give you one other quick example.
Yeah.
Monosodium glutamate, MSG.
Yeah, MSG.
And again, so what happens if you add the MSG to foods that are low in protein? Glutamate is a neurotransmitter, and you get a lot of MSG in the bloodstream all at once. That's monosodium glutamate. Glutamate can flood into the brain, and some people are more sensitive than others. You can get what we used to call Chinese restaurant syndrome. So you can get some problems from MSG in that situation. But then people are starting to say, well, you can't have hydrolyzed protein because it's got MSG in it. Monosodium glutamate. So anytime we digest protein, guess what? We just digest it to the individual amino acids, one of which is glutamate. And when we go into the intestine, it gets neutralized to monosodium glutamate. Guess what? Every time we eat protein, we produce monosodium glutamate. But here's the difference. If you have all those amino acids going into the bloodstream at once because you've eaten a protein, they compete with each other for entry into the brain. So you're no longer flooding the brain with monosodium glutamate. So again, you eat whole foods, you do pretty well. It's when you start, adding too much of something and, it's out of balance. That's where you run into problems.
Last thing before we wrap up, I don't want to keep you from your family too long. Let's talk just a little bit about, and I love the fun about Korean. I'm like, that's seaweed. Are you going to eat sushi? GMOs. On the other interview, I heard you talk about that some GMOs, we don't have to worry about them because of the way they come from. And I'm talking about how they get processed by the time they're done. And I think that's one of those. And I want to be clear too, something that's hybridized, like when you make a plant a hybrid, you have not made that a GMO. A GMO is narrowly defined as, take it from there. What is a GMO?
So when we talk about, let's talk about plant breeding, which is there are a lot of food, we have a ton of foods out there that aren't truly natural because they didn't exist if we were Paleolithic. They didn't exist in Paleolithic times. They were, they were bred, they were selected. You would take the flower and you would pollinate it with the different species, and you would select the best things that came out of it. Things like nectarines. Those didn't exist in nature. We created those, but they're perfectly healthy. With genetic modification, you can take totally foreign proteins that were never even in another species of fruit, and you can introduce them into a fruit or vegetable or a grain or whatever you're trying to do. So here you've got a couple of issues. One of those issues is the DNA. You have foreign DNA there. Now, it's theoretically possible when we digest that food that we have a little bit of that DNA. It might get into bacteria, which might get it into our system. It's never actually been shown to happen, but it could. It's theoretically possible. So the DNA is a theoretical concern. The protein is probably more a real concern because you've got a modified protein in there. And anytime you have a modified protein, some people are going to have allergies to that.
Because that's what the immune system identifies. It's looking for the protein molecule.
Right. Now, again, not everybody's going to have problems. Some people will have sensitivities to that, just like some people are. My father was very unfortunate. He was allergic to chocolate. I can't imagine a worse fate. But anyway, be that as it may. So we all have food sensitivities. We learn to cope with them. But in this case, you've got these foreign proteins in there that you aren't suspecting. And you don't know about avoiding that particular food. And some people will be allergic to it. They could have very significant symptoms. The problem is it's very difficult to quantify food allergies. We don't know how significant a problem it is, but it's certainly possible. Certainly one that we should be concerned. So that means I'm not saying that there are foods that are genetically modified that we don't need to worry about. Foods are going to contain DNA and modified protein. So that could be a concern for some people. Not for everybody, but for some people. If we take protein that's been from a genetically modified food, that again, you've got a different species of protein in there. That can be a problem for some people. Not for everybody, but for some people. But once you have purified things like sugars or oils or a lot of other food ingredients that are taken from these foods, there's no DNA. There's no protein. They're chemically and biologically indistinguishable whether they came from genetically modified foods or non-GMO foods. So that was sort of my beef with the labeling laws that so many people were promoting, and this GMO project were promoting, where everything that had ever come from a GMO food needed to be labeled GMO.
So it was too broad of a brushstroke.
Too broad of a brushstroke. It didn't make any sense scientifically. So
should we avoid, and like when it comes to corn, it's almost extremely difficult to avoid GMO corn unless you don't want to eat corn. Are those foods that you would advise your children to not purchase and eat, or that you don't eat, or is it you're just going to have to kind of know?
Yeah, I think that's one of those things. You talk about doing an elimination diet with your relative that had the autoimmune disease. I think if we do a good job of really noticing what effects we get with certain foods, we can pick out most of these problems, with good detective work. We just need to be better at learning to listen to our bodies.
Awesome. Well, I think you're done, Dr. Chaney. I think there's no more questions coming in.
Good.
I wanted to thank you so much for being here. Now, you guys can get this on Amazon. What, Tori, is there one more question? We're waiting maybe on one more. Oh, can labeling on certain food be deceiving? I think there's just a lack of trust in what people see when they're buying things in general.
Yes, I've got a whole chapter on that.
You do, actually. You have to get the book.
But yes, I mean, sometimes one of the ones I really love is this idea of fruit and vegetable powders. You really, there's some of them that can be very good, but you've got to do some really rigorous quality controls to make sure that they actually deliver the nutrients they're supposed to deliver. Most companies don't do that. So you'll find these chips in the market, various things. They tell you, oh, they got these fruits and vegetables in them. Well, those are fruit and vegetable powders. They sprinkle a little powder over it. It's kind of like fairy dust. And they tell you all these fruits and vegetables that are in there. But, there's not enough of them to make, not enough nutrients from those fruits and vegetables to make any difference.
So like I had one, as I was asking one nutritionist about orange juice.
Mm-hmm.
And I said, in theory, if a cup of orange juice really did have 100% of what I needed for the day in terms of vitamin C and all that good stuff, that would be it. I'd be good. And I'm not. And just before we go, do food companies test when you're looking at the label and it says this much iron, this much calcium, this much vitamin C, or whatever? Are they really testing those foods to make sure that that's what's in there? Or are they working off a chart?
Often they're working off a chart.
They're working off a chart. So they're making an assumption.
They're making an assumption, yes.
Okay. And that's why I take vitamins. All right. Dr. Chaney, you have been awesome. Thank you so much for your time. And we're going to be giving away a book tonight. So after we'll release Dr. Chaney, and then I'll go ahead and do a drawing for one copy of his Slaying the Food Myths. And the other one's going to be on Freebie Friday. So that means you guys have to come back on Friday. You, Dr. Chaney, can come back anytime. And you've got another book coming out. When's your next book coming out?
Well, it'll be September, October. These things are always a little bit hard to control. And my first book came out about a month or 2 months later than I thought it was going to come out.
Mm-hmm.
I guess about a month and a half.
And the other thing is you've also got a science symposium again in October. Is that about right?
We have Dr. Daggy coming out to Chapel Hill, North Carolina. That's actually September 29th.
September 29th. So I got to mark that down.
So
all right.
Put that on your calendars.
All right. Dr. Chaney, thank you again. It has been a pleasure to have you. Just grateful for all the questions that you've taken. I think I'll go back in and I'll see the comments. I think everybody's really glad. So thank you again so much. God bless you.
You're very welcome.
Bye-bye.
Bye.